Hey there. Today we're going to look at how we can deploy Node.js Microservices using AWS. So we'll use AWS EKS to deploy microservices to a Kubernetes environment, and we'll be able to access an externally available API using a load balancer. We're going to go ahead and deploy the microservices we built using Nest.js in the previous video. So if you haven't seen that video yet, I highly recommend you check it out. I'll include a link in the description. So let's go ahead and get started in deploying these microservices. I'll see you there. So firstly, we're going to go ahead and clone the existing project that we have already completed in a previous video. I'll include a link in the description to the GitHub repository to where this project lives, as well as a link to the video itself if you'd like to take a look at how we set this project up. So once we have the URL for the repository, we can go ahead and clone it. So this is the Nest.js RabbitMQ microservices that we have already created. Now we should be able to ls, and then we can cd into this folder here. And then we can go ahead and feel free to open up our code editor and view this project. So as I mentioned before, this is the project we've already created with our 3 different microservices: auth, billing, and orders. And inside of each project, we have a Docker file which lays out the set of instructions for how to actually build and deploy this application inside of Docker, which we're going to need to be able to actually deploy our application to AWS. So in order to help us deploy our application in a Kubernetes environment on AWS, we're going to use a package manager for Kubernetes called Helm. Now, if you're not familiar with Helm or how to install it, I'll include a link in the description where you can read more about what it is and how to actually install it, which is quite easy to do. If you're on Mac like me, you'll be able to run brew install Helm and simply install it locally quite easily. I already have it installed, so we can go ahead and continue. Now, before we go ahead and continue, I'm going to go ahead and check out a new branch on our existing repository to EKS. And so all of the code for this video will be on this specific branch. If you'd like to check it out and follow along, you can feel free. So with that on a new branch, we can go ahead and actually create a new folder in the root of our project called Helm. And this is where all of our Helm charts are going to live. So now that we're ready to move forward, let's go ahead and create a new folder in the root of our project called Helm, which is where all of our Helm charts for this application will live, which are the set of instructions for how to deploy a given application. So back in our terminal, we can do ls and we can see our new Helm folder. Let's cd into it, and now we can use Helm to actually create a new chart. We can use Helm create and then call this ordering app. We can see it's gone ahead and created ordering app. And now back in VS Code, if we open up Helm, we can take a look at what Helm has created for us in this ordering app directory. So firstly, it's created this chart.yaml file. And this chart.yaml file is essentially the base manifest to describe this application. We have the API version for Helm, the name of the app, a description, type, version, and application version. And importantly, we're going to use this chart.yaml to include dependencies on other charts that we want to bring into our application later on. Moving forward, we can see we've created a templates folder. Now the templates folder are the list of the Kubernetes resources that we actually want to get deployed when we deploy this Helm chart. We're not going to actually use any of these out of the box, so we can go ahead and actually delete everything in this templates folder for now. And then lastly, we have a values.yaml file which lists the overrides for our templates here, so we can specify different values that we want to be populated within our templates when we deploy a given chart. We don't need any of these preset values here, so we can go ahead and remove all of this information as well. And then lastly, we have a Helm ignore, or just a set of files we want to ignore. So now we're ready to go ahead and actually set up the instructions for our own applications. So to do that, inside of our templates directory here, let's go ahead and create a set of folders for each of our apps. So we'll have one for orders, billing, and auth, of course, because these are our 3 microservices. So the first template we're going to create, of course, is the deployment itself, which is going to describe how to actually run our application. So now we need to specify the deployment. And if you're not familiar with Kubernetes deployments and how all of this ties together, I will include a link in the description so you can read a bit more. We're going to go ahead and get started by describing the API version that we want to use in Kubernetes. This will be apps v1 with a kind of deployment. We'll give the metadata here and provide the name. So we'll just call this orders. So now we can provide a spec here, and we'll specify how many instances of the orders app we want running. I can say 3 to start off. And then importantly, we're going to need to provide the selector here so that our deployment actually deploys the correct application. So we'll say that we want to deploy the app with a label called app orders. And so we'll use this in a second here when we define the second section, which is the template, which is the actual information about the application running. So we'll give some metadata here now. Metadata. And this is where we provide the label for the actual pod that will be running. And this is how this gets matched up here. So we have an app orders for our labels here. And then we can specify the actual spec for the running application. We'll provide a containers section here where we'll provide the information for the running containers. So our first container and only container will be the orders container. So we'll call it orders. And then now we need to provide the actual image for this container. We want to be able to deploy this and pull an image from anywhere when we actually deploy this, whether it's locally or in Amazon EKS. So to do that, we're going to have to go ahead and build our Docker images and push them to a central repository. In this case, we can use Docker Hub. So I've gone over Docker Hub in a previous video, but you can navigate over to hub.docker.com. And once you sign in or create an account, you have the ability to go to the repositories page, and then you want to create a new repository for each one of our microservices. So you can see here, I have one created for ordering app _ orders, ordering app _ auth, and ordering app _ billing. You simply just need to create a repository with your account, give it a name, and you can go ahead and create it. Make sure it's public because by default you can only create one private repository. In order to actually push our images up to our Docker Hub registry, we can go into our apps directory, and for each one of our apps, we can go ahead and use the Docker file to build the Docker image and then push it up. So if we were to go into orders, we could run docker build, and then we specify the root context, which will be 2 directories up at the root of our project. And then we can specify the Docker file, which is at the root, and then we give it a tag. So this should be the same name as our repository in Docker Hub. So in this case, it's mgui/ordering app _ order. After your Docker image has finished building, you can then run docker image push and then provide the name of the repository, assuming it's your repository. This will allow you to push the image up and then use it in your deployments. So once it's public and you have all 3 of these, we can then go back and actually specify in our deployment that we want to pull this from your account name. So in my case, this was mgui. You could use my account because it's public, or you can use your own, whichever you feel more comfortable with. And then we can specify the ordering app _ orders image, which will pull from that Docker Hub repository. So next we'll go ahead and specify ports here. So we know we have a container port for this ordering image that will be running on port 3000, listening for HTTP requests. And our final section here will inject some environment variables for the running container. Now, of course, the first one we know out of the box, we'll have to specify the port, and we'll give it a value of 3000. Now we also have a couple of other RabbitMQ environment variables, and if we want to go actually and check in our apps orders.m file, we can see all of the environment variables that we need to inject here. Of course, we'll need to inject MongoDB and RabbitMQ URIs, but for now we don't have these running, so we'll come back to them later. For now, let's just go ahead and provide these queue names here in our M file. So we'll go ahead and add a couple more environment variables here. One for the billing queue. And so you can see here we have our RabbitMQ billing queue, and our auth queue so that our orders application can successfully communicate with billing and auth. So this is everything we need really to actually deploy this application. Of course, we still need our MongoDB and RabbitMQ running, but for now, this is a basic deployment. Let's go ahead and set this up for billing and auth quickly. So I'll call it deployment.yaml again for billing. And to make things a bit quicker, we can simply just copy over our existing deployment here. And so this will be the set of instructions for how to deploy the billing application. So most of this is going to stay the same. We'll of course change the names here to billing. We can keep 3 replicas and make sure we just change the label app to billing. The name here will be billing as well, and make sure our image repository is pointing to the billing repo. Make sure you've also created this if necessary. Now, of course, billing is listening only on RabbitMQ, so we don't have a port here, and we can remove this section here, as well as removing the port environment variable. Similar to orders, we'll have to come back and specify the RabbitMQ and MongoDB URI in a bit, but for now, this is everything we need for this deployment. So let's go ahead and set up our final deployment for the auth microservice. So as we've done before, we'll go ahead and paste our existing deployment in here, and we can go ahead and simply change the name of the app here to auth. So we'll go ahead and change all of this information, change the image repo here to app_auth as well. We will go ahead and also add a port section now, because we have a container port listening on 3001 for HTTP requests. Now, additionally, if we go ahead and look at our auth project here on the .m file, we can see we have a few more m variables we need to inject. We need the port, of course, but we also need the JWT expiration and the JWT secret. So let's go ahead and provide these. I'll go back to the deployment here, and I'll go ahead and add these additional environment variables. Now, importantly, we don't normally want to actually explicitly provide the JWT secret or any secret sensitive information as a hard-coded environment variable here and then commit it to a Git repository. This is bad practice in production. Normally what we want to do is actually create a Kubernetes secret, and then we can reference that secret directly here in the environment section. Now, I'll leave a link in the description for more on Kubernetes secrets in environment variables so you can implement this yourself. But for now, this basic example will allow us to proceed with our deployment. So our final environment variable we need now is the port. So I'll go ahead and provide the port of the value of 3001. Okay, so with our 3 deployments running, we can go ahead and actually try to deploy this application. So of course, make sure you have Docker running on your system. And once it's running, we can go ahead and open up our terminal. And in our Helm project, make sure we cd into ordering app. And then we can simply run helm install the name of the application we want to install. So in this case, it'll be ordering app, and then the path to the Helm chart. So in this case, it's in the relative path. It's right in this directory. So we'll just put a period here. And then we can go ahead and deploy this application. So when installing, we can see we have an error here on line 16 of our auth deployment. So let's go ahead and check that out. So Helm will automatically tell us if we have any issues with our deployments. So looking at line 16, we can see our indentation is off for this section here. All of our container related information should be indented 1 more block, and we'll have to go ahead and do this same for the billing. Make sure the indentation is okay, and again, same for the orders deployment here. Make sure our indentation lines up as so. So we'll go ahead and try installing again with helm install ordering app and provide the path here. We can see we have a duplicate name RabbitMQ auth queue, but that's just a warning, and then our chart was successfully deployed in our default namespace. So now, making sure that our Docker desktop is running with Kubernetes, of course, we should be able to run kubectl get pods, and we can see we have some new pods running with some errors being thrown, most likely because we don't have MongoDB and RabbitMQ running. So going back into our auth template here, we can remove this duplicate auth queue because we have this specified twice. And if we go ahead and take a look at our pods, well, we can see our auth pod is running. So let's take a look at the logs here. We can see we're having trouble connecting to the database. And of course, this makes sense because we don't have a MongoDB instance running right now. And so if we look at billing as well, we can see we have a config validation because our RabbitMQ URI isn't provided. So let's go ahead and fix these errors by setting up RabbitMQ and MongoDB. So as I specified before, we're going to use third-party Helm charts to implement our dependencies on MongoDB and RabbitMQ. So I'm going to use this service called artifacthub.io, where we can find, install, and publish Kubernetes packages using Helm. So to see what I mean, we can look up MongoDB, and we can see the Bitnami MongoDB Helm chart here, which is what we want to install. So in here we can see all the information about this Helm chart, and we can also see how to install it with the command line, but more so we can also see different parameters that we can override using that values.yaml file we looked at earlier. So we'll go ahead and override some of these values in a bit. For now, let's go ahead and actually include this chart in our project, which is very easy to do. We just need to open up the chart.yaml here. Let's scroll down and add a new section called dependencies. And inside dependencies, we can list the other charts that we want to install with this chart. So in this case, we know we want MongoDB, and then we want to provide the version of the chart that we want to bring in. So let's go ahead and look at the latest version. We can see it's 12.1.20. So let's bring it in, 12.1.20. And then we need to provide the name of the repository where this chart actually lives. And so if we look at the repo that we're adding using the command line, this is the same chart URL that we want here. So let's copy this and paste it in here. So now we have a repository for MongoDB. We're going to go ahead and do the same exact thing for RabbitMQ. We're going to use the RabbitMQ Bitnami chart as well. So we'll do the same thing. We'll call this RabbitMQ. We'll go ahead and grab the version back in Artifact Hub. Let's look up RabbitMQ. We want Bitnami, and we can see the latest version is 10.1.8. So let's go provide that. And the repository will be the same as our MongoDB, coming from charts.bitnami. So let's go ahead and just paste this in. So now we are bringing in these charts. We want to override some values like the password and the architecture for MongoDB. So as I said before, we're going to use the values.yaml for this. Now, if we go into the Helm chart for MongoDB, for example, we can see that in order to implement a replica set, for example, we need to provide that value in the values.yaml. So we'll provide architecture replica set here. And if we also look for root password, for example, we can see we need to override the auth.rootPassword to provide the root password. Now, as I said before, when providing the JWT secret, it's not great to list out the password in plain text if we want to commit this code to a repository. Instead, we could also use auth.existingSecret to use a Kubernetes secret with the password. Now, we're not going to do that just to keep things more simple, but you can easily use this approach as well if you'd like to keep your Helm chart a bit more secure. So let's go ahead and implement these overrides. So in order to specify an override for a dependent chart like this, we will use the same name that we provided here. So in this case, it's MongoDB. So let's go ahead and override some MongoDB values. Now, firstly, the root architecture value we can override as we saw, and we can provide the replica set architecture. Now this is because we need a replica set running for database transactions, as we've seen in the previous video. And we can also provide the auth section here. As we saw, we want auth.rootPassword to override. And we'll just give this a plain text password of 123. Now, as I said before, we can also use secrets to make this a bit more secure. For now, this will work. And then we'll go ahead and do the same for RabbitMQ. RabbitMQ has a auth section as well. If we look at the RabbitMQ Bitnami chart, we can see auth.username, password, and we have the same pattern where we can provide a password secret as well. We're going to use plain text to keep things more simple here. So we'll have auth, and then we'll have the username. I'll give a username of user1 and a password of password123. So with this, we should be able to include MongoDB and RabbitMQ with some overrided values here now. So let's go ahead and open up the orders application to start. So now that we have these dependencies part of our Helm project, let's go ahead and Firstly, we can use Helm ls to view our existing deployments. So let's go ahead and actually uninstall this deployment, because when we bring in MongoDB and RabbitMQ, I want this to be on a fresh chart. So I'll go ahead and make sure we use uninstall correctly here on install. So ordering app is uninstalled. So we're gonna do the same command we did before, helm install ordering app. Now you should see that you get an error because we have missing dependencies in our charts directory. Now in order to actually bring in these dependencies we specified, we need to run helm dependency update. And so it's gonna go ahead and grab the dependencies from the charts that we specified. And now once we've done this, we should be able to run helm install ordering app. And we've actually gone ahead and deployed this chart now. And if we look, we should now see our MongoDB pods running as well as our RabbitMQ pod. Now the important piece we want to look at now is to run kubectl get service, because we need to look at the services in our cluster that will be used to communicate to these pods. So in this case, we want to actually use the ordering app MongoDB headless service here to communicate to MongoDB. This service will allow us to communicate to the MongoDB pod on port 27017. And for RabbitMQ, that chart creates a RabbitMQ service for us to communicate to RabbitMQ on port 5672. So let's go ahead and use this information to create some connection URIs. So let's open up our orders deployment, and we'll firstly go ahead and add the MongoDB URI. And so we'll give this a value. Okay, and the value here, of course, it's still going to be that MongoDB connection string format. Now we're going to provide the username and password. So by default in the Bitnami chart, the username will be root. You can override this in the values.yaml if you'd like. And then the password, of course, we know is password123 because we overrode that with password123. Now similarly, this is insecure. If you want to provide a secure way to inject this, we can use Kubernetes secrets. But for now, we'll continue with this. And so now we use the @ symbol to specify the host that we want to connect to. Now, as I said before, we want to connect to the ordering app MongoDB headless service. So this name will always stay the same. So that's why we want to copy this host here and actually use this host in our cluster to communicate. And then we'll provide that port of 27017. So now we should be able to connect to MongoDB using this connection string. So now we're going to do something very similar with the RabbitMQ URI. So the value here will be amqp://user1, which is the username we provided with password123 now we need that service name, ordering app RabbitMQ, and this will be 5672. So now we have these two connection strings. Let's go ahead and provide them to our other services as well. So we'll just simply go ahead and paste these in to the auth project here and make sure our indentation lines up. We can do the same thing for auth as well. So now all these new environment variables have been added. Let's go back to our command line now. We can clear out our existing output. And if we don't want to uninstall our chart each time that we make changes, we can run helm upgrade. And then we can provide the name, so ordering app, and the path. So now we've gone ahead and upgraded ordering app. And so it will redeploy any pods that have changes detected. So in this case, it'll redeploy orders, auth, and billing. So after we give our application a few minutes to bring up and allow things to start up properly, we should be able to look at the logs now for each of our apps. So for our auth app, we can see that our Nest application successfully started. So we're listening to HTTP OK, and our Nest microservice started. So we were able to connect to the database and our RabbitMQ service, which is awesome. So let's go ahead and look at billing as well, make sure this all looks okay. That looks good. And finally, we'll look at our ordering app. So let's take a look at that. It looks like we've started okay, which is good to see. So let's go ahead and actually test our app out in Postman. So right now, we don't have any of our applications exposed through any services. We have our MongoDB and RabbitMQ exposed internally through services, but our actual apps themselves aren't. So let's go ahead and fix that. We can run kubectl expose deployment auth, give it a type of node port. And node port will allow us to communicate to our app outside of our cluster. And so we have that type of node port, which is important. And then we can give the port So we know auth lives on port 3001. So we've gone ahead and exposed it. So now we're running for kubectl get service. We can see we have an auth service with a node port, and we want this larger port here. This is the one we're going to use to communicate to it on 31378. So now let's open up Postman, and we should be able to run a post at localhost with that port name that we copy over, and we can run a route on auth.users to create a new user. I have an email and password, and if we go off and send this request, we can see we have our user created because we've gone ahead and sent this to our node port service, which will then route the request to the auth pod, one of the 3 pods running, because you remember we have 3 of them running. So we're able to create a user, and we can try even logging into our app now. So we've logged in, and we can get that authentication cookie that we know we get. And finally, we can go ahead and expose our other deployment, and this will be the ordering app. So let's go ahead and change the port to 3000 here, and we'll expose orders. So now let's go ahead and kubectl get the service, and we'll look at orders. We can see our orders app is listening on 32348. Let's get that port, and now we can send a request to create a new order, and this will use the authentication cookie that we have. You can see here, and we're able to create a new order. We can try creating a few, and then we can launch a GET request to look at the orders, so we can see that they're persisted in our MongoDB database. So now at this point, we've pretty much deployed our entire application using Helm locally. So before we set up AWS EKS, you need to make sure you have an AWS account and that your AWS CLI is authenticated and configured. So I'll go ahead and include a link to this documentation here for how to create an account and set up the CLI. Now secondly, we're going to use a tool called EKS which is an amazing command line utility for creating and managing clusters on EKS. It'll simplify the whole process for us and make it extremely easy. Now, I'll also include this link in the description to how to set up EKS on your computer. There's simple instructions here for how to install it. So in order to move forward, you should be able to run EKS version here and see that you have a version outputted. And so we can simply run a command EKS create cluster, and I'm going to give it a name of ordering app. I'm also going to specify the region here to US East 1 because that's the region closest to me. You can specify whichever region is closest to you. So we'll go ahead and create this cluster, and by default this cluster will use 2 middle tier M5 nodes, which are relatively inexpensive and will work exactly for our deployment. So this will go ahead and create a CloudFormation template for provisioning all the resources we need in our cluster. It'll go ahead and create a control plane node as well as 2 managed nodes that have all the resources we need to deploy our app, and it'll automatically update our kube config for us so we can communicate with this cluster. So go ahead and just let this CloudFormation stack complete, which may take a few minutes. So in order to create a load balancer for our application, we're going to use a Kubernetes ingress resource and take advantage of the AWS load balancer controller, which will automatically provision us an application load balancer, which will take external HTTP traffic and send it to our underlying Kubernetes deployments for us. So in order to do that, firstly, we're going to need some services running for the deployments that we want load balanced. So let's go ahead and open up our Helm chart again. And in our templates folder, firstly, we'll create a new service for orders. We'll go ahead and create a service.yaml here. And so this API version will be v1 kind service. We'll give this a metadata, and we'll call it name orders, and give it a spec here. So this will be a simple spec with a section for ports. This port, we know, of course, will be on 3000. The protocol here will be TCP, and the target port will similarly be 3000 because that's where our app is listening. So this is going to be a clustered IP service, which is only usable with inside of our cluster, but it's going to be required so that our ingress can communicate with it. So now we need to provide the selector, which tells the service where to route the traffic to. So in this case, we know the app will be of app orders. So let's go into auth and we'll create a similar service here. We'll create a service.yaml in auth as well. And we can go ahead and copy this service over. All we have to do is go ahead and change the name here to auth. So we'll go ahead and change this to auth, and then we'll change the port here to 3001. So now we have two services that can be used for our ingress resource. So let's go ahead and actually create a new ingress.yaml. So we'll call this ingress.yaml, and this is going to be the ingress we describe, which will automatically provision the load balancer for our application. Let's go ahead and create this ingress resource here. So the API version will be networking.k8s.io/v1. The kind here will be of kind ingress, and we'll give it some metadata now. So specify the name, and we can call it orders ingress, and we'll call it ordering ingress. You can call it whatever you'd like, but importantly, now we need to provide some annotations. And so these annotations are important for the AWS load balancer controller to actually pick up on this ingress resource and create an associated load balancer for us. So let's go ahead and provide these annotations, these two annotations here. Firstly, specifying this is an internet-facing and external traffic-based ingress. So we want a load balancer created for it. And then we also want the target type set to IP here. And if you want to learn more about these annotations and how all this works, I'll include a link in the description to the docs for the AWS load balancer controller. But out of the box, this is everything we'll need to set up the load balancer. And so now we can provide the actual spec here. So we'll have to give the spec an ingress class name here of ALB for an application load balancer. And then finally, we'll provide the actual rules for our ingress. So we have HTTP based rules here, and we're going to have paths set up here. So we're going to have a set of paths that we want to route traffic for. So our first path here will be for /orders. Now, any traffic that comes on /orders, we'll specify that the path type will be prefixed so that we match it exactly. And then we'll provide the backend we want to route this traffic to. So in this case, we have a service we just created, and we know that the name will be orders. And of course, the port will be on port 3000. And so we can go ahead and copy this block here and fill in the same exact thing for our auth route. So we'll give it a path here of /auth. This will be path type prefix with a backend service. And we know we've created this cluster IP service of name auth, and the port is on 3001 now. So now we have our two paths here to route traffic to the appropriate services, and we have a load balancer that will route all of this traffic for us. There's a couple of mistakes we need to correct. Make sure we capitalize our ingress here. And then secondly, make sure we actually remove this dash here from our path section, and make sure we keep our indentation. So we should not have a dash for that path. So after our EKS cluster has been created, you should see that we are able to run kubectl get nodes. And we can see we have two nodes provisioned for us by EKS. And we can run kubectl get pods to see that we have no pods currently running. So the great thing about our Helm installation is that Helm allows us to install the same project in any Kubernetes cluster. So we did it locally, and now we can simply do it in EKS with one command. So before we can actually deploy our ingress, we need to make sure we have the AWS load balancer controller actually set up and installed. So I'll include a link in the description for these installation instructions, but we'll go ahead and walk through them as well. The AWS load balancer controller is what is actually responsible for creating the underlying AWS resources or the load balancers when we want an ingress provisioned. And we can see that if we go to the home page here, we can see that it satisfies the Kubernetes ingress resources by provisioning ALBs, which is what we'll want. And it also satisfies Kubernetes service resources by providing NLBs if required. So we'll go ahead and back the installation instructions here, and we'll walk through the instructions that it specifies. So let's scroll down to the first instruction here, and we'll copy this command where we create a IAM OIDC provider. So let's go ahead and copy this command to our clipboard, paste it in here, and we'll just need to go and change our cluster name. So in our case, we'll change the cluster to ordering app, and we'll go ahead and change our region to the region where we created our cluster. So in this case, for me, this was US East 1, and we'll go ahead and create this provider. So after that provider was created, we'll go to the second step, and it says we need to download the IAM policy for the controller. So let's go ahead and download that policy, and then we'll copy the third command here where we create the IAM policy. So let's go ahead and create that. We have the name and the policy document file. So we'll go ahead and run this command, and you can see I have an error occurring because this policy already exists, and that's because I've already done this step. So that's okay. Just make sure you've run it and created this policy at least once. And lastly, we'll go ahead and create the IAM role and service account for the load balancer controller. So go ahead and copy this, and we can go ahead and paste this command in. So you're going to have to include your region again. So in my case, this is US East 1. We'll leave all the existing flags here, and then you're going to have to provide your AWS account ID. Now this account ID should be returned when you have created that previous step. So go ahead and copy that ID from here and paste it in. Now if you're missing this ID, you can simply get it by logging into your AWS account. So if you need to obtain your ID, you can log into the AWS console and then click on your username here, and your ID will be populated in this drop down. So go ahead and provide your AWS account ID here, and then lastly, you'll have to provide the cluster that we are applying this to. So in this case, this will be ordering app. And with that, go ahead and complete this command. So after you've gone ahead and created that service account, you should see a successful response, and then we can go down to actually adding the controller to our cluster. So these commands are quite simple. We'll have to go ahead and add the repo here using Helm. So let's go ahead and add the repo. You can see I already have it, so it's going to skip it. So that's fine. So go ahead and add that repo. We can skip this step here because we're going to run Helm install. So we're going to go ahead and copy this third command here where we install the load balancer controller. And so we'll go ahead and provide the name of the cluster that we want to apply this to. And you can also see it's going to install it to the kube system namespace. So we'll provide the name here to ordering app. So after installing, you should see that it installed successfully, and then we can run kubectl get pods under the kube system. And we should see that we have an AWS load balancer controller, 2 of them running here in our cluster. And so now we should be able to run helm install ordering app at the root directory, and make sure we spell install correctly here. So it might take a couple minutes for it to install properly, but after it's deployed, we should be able to run kubectl get pods, and we can see our application workload starting up. And then if we run kubectl get ingress, we can see our ordering ingress here with a class of ALB, and we can see we have a Kubernetes load balancer address that has automatically been created for us. If we open up in Postman, we should be able to type in this address here. So http:// and then we can run /orders to start to see if we have any orders in our system. Now we have some issue connecting to this load balancer, and that's because it can take a few minutes after our load balancer is created for the DNS resolution to take place and for our requests to complete. So let's wait a few minutes until this is finished populating. Okay, so I've waited a few minutes for our load balancer DNS resolution to occur, and now we can send a request to get an empty array of orders because we have none in our app. So let's go ahead and launch a request to /auth. And if you remember, the load balancer ingress will direct the traffic to the correct pod, and we can create a new user here. So let's go ahead and copy our post request from our local host and provide it here. So we'll send a user in, and of course make sure we change our request here to post. So we'll go ahead and post a new user, and we get that new user created. We can also go ahead and now launch a login request. So we get that HTTP cookie. So we send a login request, and we got that auth cookie, which is good. And so now let's change the route here to /orders. So we have /orders here, and we'll change the body now to a new order. Go ahead and provide a new order here, and we'll go ahead and launch a few orders to be created. Now let's go ahead and query the orders in our system. we can see we get back an array of orders. This has been a quick example of how to deploy a Nest.js microservice application to Amazon EKS. We can see all of our pods running successfully inside of our application here. And we also should be able to see, if we actually look at our logs for our application, we get different billing requests coming in. So we can see our application is correctly tied in together. So if you'd like to see more videos in the future about EKS, deployment, Nest.js, and microservices, make sure you subscribe and stay tuned. Thanks for watching, and I'll see you in the next one.